Hey everyone, welcome back to KBS Technocraft tutorial Mastering Unit Tests using pytest Part 2 Parameterized Tests using pytest in Python. Today in this tutorial, we are going to discuss and understand what are parameterized tests and how we can implement using pytests and Python. Then we will also cover in more detail about the scenario based example and try to understand how to write parameterized test. And in the last, we are going to understand by this scenario what is the advantage of parameterized test. Before we dive into today's video, I wanted to take a moment to invite you to join my channel KBS Technocraft. If you like what you see, please consider hitting the subscribe button. By subscribing, you will never miss out on our latest video and updates. Your support through subscribing would be greatly appreciated and it will help me to continue creating valuable content for you. So, we will try to create a folder, and that folder we will give a name called parameterized tests. So before we proceed on the technical example, we will try to understand what is parameterized test. When you want to write a test which is data driven, when we say data driven, that means the same test case can run with a different set of data. In that case, we will use parameterized test cases. Okay, so we'll take example and we'll see how we can implement it, and then also we will take a real-time scenario and we'll try to understand what is advantage and disadvantage of parameterized tests. Before we proceed next, I would highly recommend that if you know how to do the environment setup for pytest, then it's fine. If not, please go and refer the part 1 video where I have covered the environment setup part. So here I have done environment setup for this folder, and you can see I have a folder called parameterized test, and then I have all this predefined environment setup file. When you create a virtual environment, you will have this all files over here. Now what I'm going to do, I'm going to create a simple program, and then once we understand about the parameterized tests, then we'll take a scenario and we will work on that. So in this, I'm going to write a factorial calculation, let's say, and then at this, I will put it outside. Let me delete from here. I need to put outside. I do not want to mix with the environment specific file. So I just here calculate factorial py, and then I will write a function factorial, and I will pass a number, and then I will use recursive concept. So I'll put if number is exactly equal to 1, then return 1, else return number multiplied by factorial number minus 1. So this is a very simple recursive function where I'm calling factorial inside factorial, and we will test this function is working fine or not. So we will try to print, and then factorial, and then number will give 5, and we'll see that for 5 it's giving 120 or not. So let's say you can see it's giving 120 because factorial 5 equal to 5 into 4 into 3 into 2 into 1, so it's 120, it's giving 120. Now let's say try to write a parameterized test case for this. So we will have a test data. Let's say consider we will create a data called test data, and then in test data we will declare array here, and then let's say consider we pass 1. When you pass 1, then it will return 1. So in this, the first one is First one is two. If you are able to see in this, there are two parameters. The first one is input, input, and second parameter which I am passing here is expected value. So I will make couple of set. Let's say consider as of now we have three set of data which we want to test it that for this. So if I pass 2, in that case my factorial should calculate it 2 into 1 is 2, and if I pass 3, then the factorial should calculate it as 6, and let's add one more. So I will add it 4, and if I pass 4, then it should give me 24. 4 into 3 into 2, so it should give me 24. So this is my data. So first one is input and second one is expected. So now we will declare a test function, test factorial, and then now we have this test data defined here. Now we have to pass that test data here in this function. To do that, we need to use that parameterize. So in order to pass that, we need to pass that parameter here. So let's say consider here the first parameter is for us is a number, and then second one is expected value. These are the two parameters we require to for test, and then we will be passing the third parameter as a test data. Whatever test data we are having, we need to pass it. So basically these are parameters you need to define as a string, and you have to use same name in your program. So for example, I'm giving a parameter name as a number, so I have to give number, and expected value I need to pass as a expected value, and then I need to pass the test data. Okay, now but we need to put a assert now, but before that we need to call that. So let's say consider we are having a result equal to, we will call factorial, and then we'll pass that number whatever we are, and then we will put assert, and then we'll put result equal to, let's rename it. This one we will say actual value. Then we are going to see that assert it actual value is equal to expected value. Now we need to import pytest, and then we need to use decorator and marker here. So I will use pytest dot mark dot parametrize, and then we need to pass the parameter number and expected expected value, and then we need to pass test data, and here test data is not required. So test. So what we have done it here, we have imported pytest, and what we have done, we have added a decorator marker here, mark dot parameterize, and then we are passing number, which is the input parameter, and expected values which we are expecting from this array. If you see this, the first value in each array element, it will consider as a input parameter, and the second value which we have given, it will consider as expected value. So if you have a more than one parameter, then you can have all those parameters. The last parameter or last attributes in this array element will be the expected value. Now we will go into the test factorial section, and if you run it, you will be able to see all these test cases are running. Now let's consider if I change this value here and save it and try to run this, it will get filled because this the factorial of 4 is equal to 24, and that's why it's getting filled. So now if you correct it here to 24 and save it and try to rerun it here, you will be able to see it's running fine. It's okay. So in this there are three sections. One is declaration of the function which you are going to test it, and then the test data, and then the test function where you are going to use a marker. Marker is having a parameterized function where you are passing your input parameter and expected value, and then passing the test data which you have declared, and that's how it works. Now this is what is very simple scenario. Now we will consider a real-time scenario where we are going to understand that how is useful when you are going to write a test case. So let me create a file is called test discount calculator. Okay, I will explain what we are going to do it here. So this is test text discount calculator is the test where we are going to test a certain logic written for a discount. So for example, if we consider a scenario for discount, and then we will try to write a test for this. So first we will follow TDD approach here. First we'll write the test, and then we'll write the actual implementation. So we will also create a discount calculator class where this actual discount function will be available. So I'm going to write calculator calculate discount, or we can say discount calculator calculator, right? And then here we are going to define a function, and this function will calculate discount, and will pass amount, and then we will not implement anything, we'll just pass. Okay, so when you want to declare a function where you do not want to define a definition for that, then you can write a pass. So we will follow test driven development approach, and we'll try to first write a test case for this. So let's say consider we are having this scenario where 0 to 10,000 is a 1% discount, 10,000 1 to 30,000 is a 2%, and 30,000 1 to 70,000 3%, and 70,000 1 to 1 lakh is 5,000, and above that is going to be uh, more than 10%. Now we are going to define the test first. So before defining the test, we will try to import this. I'm going to import pytest, and then I'm going to import my calculator class. So discount calculator. Okay. So now we will do a test data. So let's say consider we'll do test data and equal to, since this function contains only one input parameter, so we will have two-dimensional array here. So let's say consider. So in this scenario, if you pass 10,000, the expected outcome will come 100. And similar way, if you pass, let's say consider 30,000, then it will come 2% and it will come 600. Similar way, we will write one more, and thus we will try to make it 1 lakh. So we'll try, and then when you pass 1 lakh, then it should be 5,000. Let's say consider this scenario. Okay, we'll see this our test case, whatever we are expecting is correct or not based on this discount calculator. So now we will have a test defined. So test will define a test, define, and then define, and then we'll have a test discount calculator. Any name you can give it. I'm just giving test discount calculator. And we will decide later what input parameter is required, and then we will define result or actual discount equal to, we will now we have a discount calculator class and module, and then discount, and then we'll pass amount. Let's say consider in this way. Now since we are going to use a parameterized method, so we are going to use pytest as we have seen that, and use mark, and then we'll make it parameterized, and then we have to pass the input parameter. So here we have amount, and then similar way we will write amount, whatever the input parameter name is there in that function you can, and then we can put expected value, and then we can pass test data. Now we need to pass this parameters here, amount, and then we can copy same name here. Okay, now we have to put a short, then actual discount exactly equal to expected value or expected discount, we can put it whatever is it. So this is just where we have set up our expectation based on this test case, based on this scenario where we are having a sell amount, if it's 0 to 10,000 1%, 10,000 to 30,000 2%, like this, and then we have done it. Now if you run your test case, since there is no implementation for the function, what will happen, this test case will get failed. Let me go on the text explorer, and if you see here and test discount calculator, there are three test cases, all will get failed because there is nothing. So okay, so all test cases are getting failed. Now we will go in the logic, and actually we are going to implement the actual logic for calculation, and then we decide to test our scenario that is working fine or not. So I'm going back to the test calculator function, or let's say consider calculate discount function, and then I'm going to add a definition of this function. So we are going to add the definition of this function based on the logic whatever we have discussed in the previous. So let me paste it here. And okay, so if you see here in this function, what we are having a calculate discount, and then if 10,000, then amount into 1 1%. 1% is equal to 1 by 100 is 0.01. Similar way, we have, if amount is greater than 30,000, 2%, then 3%, 5%, and 10%. Similarly, we have done it. Now, so our function is ready. Now, this is the function based on this logic, and then our function is ready now. So we can test this function. We can run this code, and we can see that this working fine. So we pass 30,000, and then it should give me 600. So it's giving 600. That means our logic is working fine. So now we will go to our test case and run this test cases and see that how it's behaving. So let's say consider we'll run this, is getting passed. We run this, is getting failed because expected value is 6,000, but actual value is coming 600. So here our test data, whatever is there in our test case we have written, that is not correct. That means our test data, our expected value, whatever we set it, is not correct. So let me go to the discount calculator test, and here it should be 600. And if I save it and go into the test explorer and I run it, I'll be able to see all test cases are getting passed. Now, since earlier we have worked on the very simple scenarios and we try to do the factorial and add kind of functionality. Now, if you see the advantage of this, let's say consider tomorrow you are going to change this discount calculation slab. Then what we are going to do, that you are going to just change your test data here, and your all test cases will work fine. For example, let's say consider if I am going to change this 1% to, let's say consider, uh, to 4%, or let's say consider we are going to change this slab to 2.5%. In that case, what will happen, you need to just change the expected value. So 2.5% of this will be 750. Then you put 750 here, right? And you have to go in your calculator class where actually implemented. Currently, when you're going to run it, it's going to fail it. So with there also we are going to make it 2.5. So here in our this scenario, we are going to make it 2.5%. So we can make it 2.5% here. Okay, so if you save it and go in the text explorer, if our logic is correct, it's going to pass it. So if you see, this is correct path. So what we have observed, that when we are using this parameterized test, in case of any functional change or any logic change into the function for which we have written the test case, we are able to accommodate very quickly. So now we'll quickly move on the third section. As we have seen into the example, but we have done it for discount calculator, that reusability of this parameterized test cases are more. For example, if you write a single test case, it can be reused for n number of scenario to make more coverage or write the more coverage for that particular functionality. So reusability, the same test can be reused for different input values, reducing duplication of the code and effort in writing and maintaining the multiple similar test cases. Scalability, it's easy to add modified test data sets without changing the underlying test case, making it scalable for the test different scenario and cases and boundary values. Maintainability, changes to the test can be made independently of the test code, making it easy update or modify the scenarios without having modified the underlying test logic. Readability, as we have seen that readability of test cases are great because our test data is separate from the test cases, and if you want to do some changes, you just go and change the test data. And we have seen the parameterized tests promote clear separation of the test data and test logic. And test coverage, by having this kind of parameterized test cases, without adding additional test cases, we can achieve maximum test coverage, which require no effort to do that. That's all for today. Thanks for watching. Please consider subscribe to my channel. It will help me to create more content like this. So if you have not yet subscribed, please hit the subscribe button and join our channel.